Hi.
Hey, how's it going?
Yeah, great. How about you?
I'm doing well. I'm doing well. Thank you for having me here.
Yeah, can you tell us a few words about yourself and about the tool you want to show us?
Sure. So I'm Abubakar. I'm one of the developers behind Gradio. So I started Gradio during my PhD at Stanford. And basically, my goal here was so I did a lot of machine learning research at the intersection of machine learning and medicine. And so we would work with doctors, clinicians, other folks who are not necessarily machine learning engineers. And we wanted a quick and easy way to share our models with them through these GUIs, through these demos, through these web applications. And so we started an open source library called Gradio, which is used to build these machine learning demos. It's been used to build more than, at this point, 500,000 machine learning demos, including many that you might have seen go kind of viral on Twitter or in different places, like the recent Dolly Mini demo that a lot of people are using, Anime GAN, Arcane GAN, a lot of different demos. But beyond kind of the social impact, it's used at a lot of different companies. It's used in a lot of different research as well, just to make it easier to collaborate on machine learning. So I'll be talking a little bit about Gradio, kind of why it exists, some of the motivation behind it, and then a quick like practical hands-on, like this is how you use Gradio.
Yeah, quite interesting.
Awesome. Should I get started?
Yes, please.
All right. So I'll be talking about Gradio, and one thing I should mention is Gradio is now part of Hugging Face. So we got acquired as a company and kind of as an open source library. We're part of the Hugging Face ecosystem of open source machine learning libraries. And there's some cool intersection between Gradio and Hugging Face that I'll talk about as well. Okay, great. So first of all, machine learning demos. Many of you may have seen machine learning demos. So for example, recently, if you're watching this, in kind of June 2022, you might have seen the Dolly Mini demos that have kind of gone viral. A lot of different people are generating images from these prompts. And this is a really cool model that we helped build the demo around. And so anybody can kind of interact with it, and anyone can use it. And it's really cool because we're basically letting anyone use state-of-the-art machine learning model. You don't have to be a machine learning scientist, engineer, anything of that sort. If you can use the internet, if you can use a browser, you can now use or access state-of-the-art machine learning, which is pretty cool. So why are demos so important? Besides like the kind of the ability for anyone to be able to access machine learning, it's very useful for a developer, if you're a machine learning developer, to easily present your work to a wide audience. It helps increase the reproducibility of research. So let's say you're a researcher. I personally have struggled so much sometimes to use other people's research. So they publish a model, even if they publish the code, it's sometimes a hassle to be able to get the code working in your development environment. So demos are a really nice way to actually make your work accessible and reproducible by others. And finally, by making machine learning models more accessible to so many different people, a lot of different people can help and identify failure points or biases inside models. And so the demos that we'll be talking about look something like this. Like this is an image classification demo, but the same idea exists for language models, for audio, video. Gradio as a library can support all sorts of different machine learning models. Okay. So did machine learning models exist before Gradio came along? Of course they did, but it used to be quite a bit of effort to try to build your own model. First, you'd have to actually train the model, in TensorFlow, PyTorch, whatever it may be. Then you'd have to deploy the model using Flask, Docker, some sort of hosting solution. You'd have to know maybe some databases to be able to store data. And then of course you needed to know web development to build this interactive user interface. And so this made it very challenging for a lot of people to build their own models. And so that's why we built Gradio. So Gradio basically is designed to make it super simple to do all of this stuff that you need in order to build a model. And the beauty of it is it's entirely in Python, which is a language that if you're training machine learning models, you already know. So what we're going to be talking about is why we built Gradio, and then how to actually use it in production. But before that, let me actually show a little bit about like some of the demos that have been built with Gradio. So this is one example. This is called Jojo GAN. It's a model for taking an image and converting it into like a cartoonized version. And so you can put in your own image. This is actually an image of one of my colleagues, Omar. So you put in his own image, and then you can even select what kind of cartoon style you want, and it'll turn your face into that style. And not bad. I think it did a decent job here. And so you can try this out. There's lots of other ones. So this one was built by Microsoft. Of course, we're seeing a lot of demos being built by industry as well. So this is a team at Microsoft that built a demo that takes in 2 audio files, and it tells you, and like both of them, you can speak through your mic on your computer, and it tells you if it's the same person speaking both of them or if they're different. So this is used for voice authentication and things like that. So Gradio is super simple to use. All you have to do is basically specify your function that you want to run, as well as a list of what the inputs should be to that function and what the outputs should be to that from that function. And Gradio basically handles the rest. It creates this little demo for you. And the cool thing is Gradio uses the default Python interpreter. And so what that means is you can run this anywhere you run Python. You can run this from the terminal. You can run this from a Colab notebook, from a Jupyter notebook. Wherever you run Python, you can now you can create Gradio into Gradio demos from. Okay. And the beauty of this is, by the way, it typically takes just like 2 or 3 lines. You just add it to the end of your project, and now you have a cool demo. And if you want to share that demo, you can actually do that using 2 different ways. So when you create a Gradio demo, you can also create a temporary like auto-generated link. Like you can just pass that along like you would a Google Doc link or a Google Drive link, and it allows anyone to access your model for up to 72 hours. And that's completely free and super simple. You don't have to worry about hosting anything. There's another possibility though. If you want a permanent link, you can go on Hugging Face Spaces, which is also free, and you can have public spaces and private spaces and all of that good stuff. But this requires you to deploy your model, to host your code somewhere else on the Hugging Face Space servers. So yeah, they're both good solutions. We have lots and lots of people doing both. And really, I'll kind of share more about both of those strategies. But the part that I want to emphasize, and the part that gets me really excited, is that I genuinely think that we're at a turning point in the usage of machine learning. Just like with other technologies, it used to be with machine learning that it was really like academics and hackers that started off using machine learning. But now it's with Gradio and with Hugging Face Spaces, anyone who can use a GUI or a browser can now actually start interacting with state-of-the-art machine learning models, things that really, are doing amazing things in terms of image generation or voice synthesis or other things. And we have a lot of really cool demos that people have built just in the last, couple of months alone. So, so with that, I think I'll change gears a little bit and dive more into the technical details and talk a little bit about how to actually build a Gradio demo. How does that sound, Alexei?
That sounds awesome. I'm really excited to see like all this time you were showing slides. I was thinking, oh, like, I really want to see the code. So yeah, please show us the code.
Yes, absolutely. I'm sure a lot of people are thinking the same thing. So let's go ahead and open this up. And by the way, what I'm sharing here is a Google Colab notebook. So if you would like to try this out yourself, the URL for this is right here. I'll just leave this up on the screen for a second while the Colab notebook is loading. That way you can open it up and feel free to follow along. I think that's probably the funnest way to kind of see this. So, okay, so this Google Colab notebook is designed really to just make it super simple for you to try out Gradio on your own. And it has a lot of like, text that kind of explains everything. But I'm just going to skip over the text because a lot of this we've talked about already. The main thing to keep in mind is that Gradio essentially has 3 ingredients. Okay, let me just go ahead and install Gradio here while I'm at it. That way you can see it. That way we can have it ready to use. And if you're following along, by the way, if you haven't used a Colab notebook before, you can just run any of these cells. Just click on any of them and then Control Enter to run it. So we'll just run that. Okay, so what we're seeing here. So the Gradio takes in 3 ingredients. The first is a function. Now this can be any function, any Python function you have. Typically, it's mostly like a machine learning model's prediction function. So the predict function of a machine learning model, but it doesn't have to be. It can be anything. So for example, here, I have a very simple example where this function takes in an image and it multiplies it by an array that applies like a sepia filter to it. Okay. So this
Looks
is
like for an NumPy array, right?
Yes,
So
exactly.
what kind of type is it? Image is a NumPy array, right?
Exactly. Yeah, that's right. That's right. Great. Thanks for clarifying that. So this is a NumPy image as a NumPy array. Then you multiply that by another NumPy array, which is like a Sepia filter. And then you kind of just do a little bit of math and then you return that. And this final image should be kind of the sepia version of your original image. All right. Cool. So now this is the part that Gradio comes in. And you can see it's literally just, after the import, it's one line of code. It's your function, in which case sepia. And then you just say, for my input, I want it to be an image. And for my output, I want it to also be an image. Okay, because this is an image to image function. So let me go ahead and run this. And so what Gradio does is it does two things here. So first of all, it creates this little demo for you. Okay, so now I can literally drag and drop in anything. So I'm a little vain here. I'm going to put in an image of myself. And what it'll do is it'll take that and it'll basically apply it through my function. And you can kind of see the output right here. Okay.
So I imagine that it also converts the image to NumPy array, right?
Exactly. So it does all of that pre-processing. So what's happening here? So when I press the submit button, what's happening is that it takes this image, it converts it to a NumPy array. And you might be wondering, why is it a NumPy array? What if I want a different format? We'll talk about that in just a second. Then it passes it through here and then it returns it. And so it does the post-processing to convert that back into a regular image that can be displayed in the browser. Exactly. So it also does one other thing. So if you're running in a Colab notebook, it actually generates a public URL for your demo. And so this does not happen by default if you're running privately, locally, but in a Colab notebook, it does happen. So I can literally share this with you, for example, like say in the Zoom chat or with anyone else, like if you're watching this in the next 72 hours, because this link will last for 72 hours. And basically what's happening here is that this demo or this interface is available just like as a public link, like, just like as a Google Drive link or Google Doc link. You can share it around. You can share it with your collaborator, with your colleague, with your parents, whoever, anyone who can open up an internet browser can now try out your machine learning model. And so you can try this on your own images and whatnot. Now the thing I should mention is that I'll just talk briefly about how this works. So your code stays running locally. So everything is local. The only thing that is kind of deployed is a UI to your page, right? Like is kind of the UI itself. And so this handles the message passing back. So Gradio handles the message passing back from the browser to the machine where the code is running, and then takes the results and sends it back.
So actually the backend here is the Colab notebook.
Exactly. The backend here is the Colab notebook. It could also be your local workstation or a server, wherever you're running Gradio. So the beauty of that is that you don't have to worry about packaging your code or making it run on someone else's environment or anything like that. It will work because it's just the same environment. And so we call this this shadow deployment or this kind of mini deployment thing. And it's very convenient for prototyping. Okay, of course, if you want to actually get a permanent link, we'll talk about that with Hugging Face Spaces. But for prototyping, this is probably the fastest. I would guarantee you, this is the fastest way to get your machine learning model or whatever demo you have in front of other people. Okay, so I'll just show maybe one more example. Okay, so yeah, I didn't want to come back and talk about this. So you can see here that what we did was we passed in an input. We said that the input should be an image and output should be an image. And if you want to customize that in any way, instead of using the string shortcut, you just instantiate a class. And then you can customize this by passing in certain properties as well. So for example, if you actually, by default, the type is a NumPy array. You can see that here, type is a NumPy array, but type can also be file path, for example. And then in that case, instead of being passed the NumPy array in your function, it actually gets passed as a string file path, and then you can do whatever you want with it and things like that. So there's a lot of properties, a lot of customization that can happen. I won't go through all of that, but maybe what I should do is I'll just point you guys to the docs. So the website is gradio.app. Gradio.app/docs is the documentation, and you can see we have a bunch of different components. So we have the image component, which is the one that we were looking at, and it takes in different properties like type and so on. And you can do a lot of other things as well. So we have a drag and drop image editor, but what if you wanted a webcam based thing as well? So you can change that and other things like that. So we pretty much have every type of model. We have every type of component that you might need for your machine learning model, everything from images to chatbots to 3D models to plots and so on. I won't go through all of them right now, but
Just a quick one. Maybe you actually have an answer later, but I'm wondering, let's say I'm running this on my local laptop and I don't want to have a public URL. Let's say I want to have a URL of my laptop, or I don't know, a URL of my EC2 instance where this thing is running. Is it customizable or it always has to be on Gradio?
yeah, so great question. So if you are using it locally and you want a URL that or let's so I guess the first question was like if you want it just accessible from your like local intranet or something like that. Is that what you're saying?
Yeah. Yeah, for
Yeah.
example, or uh, just let's say I have a port exposed to the world on my computer and I can share the link with somebody else who is outside of my network.
Yeah. So you can do that. You can set the port that you want to use. You can set the port. You can set the address that this is running on as well. It is so we have that as parameters. So when you launch it, I don't know if you go back to the code, we created an interface and we launched it right here. And so as part of the launch, you can set various parameters. And so one of them is the server port and the server name that you want this to launch
Mhm.
on. So you can do that. The other thing that you can do, which might be easier for some people, is you can just put an authentication on. So authentication basically allows you to pass in a username and password. So if you don't mind it being like if you want a URL but you just want to restrict certain people from using it, you can actually pass in literally just a tuple of the username and password, and whoever wants to access it now needs those credentials. But yeah, there's various layers of authentication that you can put on.
Mhm.
Yeah.
Yeah, so basically, let's say if I run this on EC2, I do host 0000 port, whatever, and then I open this port on my EC2 and then share the link with whoever wants to see this.
Precisely. That's exactly right.
Got it.
Yep.
That's pretty cool, and I guess it doesn't expire in 72 hours, right?
Yes, exactly. Then in that case, it will not expire. Exactly. Just keep running locally. Yep. That's right. As long as that machine is up, if you want a permanent solution where you don't have to even manage the machine, then that's where Hugging Face Spaces comes in. And I'll talk about that briefly as well. Okay, great. And then let's see here. Perfect. Okay, so I'll just show one more example. And this is here is a machine learning demo. This is just a this is a demo that generates a musical tone. And so what it does is you can have here like multiple inputs here. So for the first input is like what kind of tone that you want to generate as a drop down. The second is like what kind of octave. So there's the slider, and this is just like a numerical type interface. You can submit it, and then it generates that kind of tone here. So we won't go into the logic behind the function. That's just doing some kind of audio processing. But the thing that I want to point out is once you have your function, you can also pass in a list of inputs and potentially a list of outputs. And what happens when you pass in a list is those things get mapped to the parameters that you have. So you can see here that the first input component will get mapped to the first component here, the parameter here, note. The second one will get mapped to octave, the third one, duration. So it maps very nicely that way. Okay. Yeah, and then you have this demo right here. And again, we have a shareable URL here because this is running in a Colab environment. Okay. So, so far I've been showing you how to build your own demos. One thing that I do want to point out is if you want to build a demo around a model that is up on Hugging Face. So Hugging Face, as many of you guys I'm sure know, has a lot of different models up right now. So I'm gonna just, so it has a bunch of different models, and maybe you see one that you want to use. Maybe you find an automatic speech recognition one like this one. Facebook wave to back to base 960H. Okay, you want to try it out. Well, you can of course download the model files. You can run inference, but you can also just do it this way. So if you do gradio.interface.load, then you pass in Hugging Face / the name of the model. So in this case, Facebook fast 2 speech 2, and you do this, then Gradio figures out automatically what is the right UI to show for that model, and it kind of wraps this UI around the model. So I can say something like, hi, I'm teaching or I'm giving a talk on machine learning. I don't know, something like that. I can submit this. And what Gradio will do, it'll handle everything so that this gets sent over to that model you can run inference, and then you can get it back. And
But
hopefully
inference is running in collab right now, or is it
so
running
actually,
somewhere
so
remotely?
this is actually running on Hugging Face's servers, because Hugging Face exposes an API endpoint for every model. And so sometimes it takes a while to run, and looks like this one might take a while. So I'll just kind of go forward. But this should generally do exactly that. It'll just kind of run it through and it'll generate an output. This is a text to speech, so it might take a while.
And I guess each model has some metadata, so you can figure out what the input should be, right?
Exactly.
Or
Every
the
model,
output as well.
yeah, exactly. The input should, in this case, be a text. Output should be a speech. We'll let this run. This one might work better because it's a faster model. So this here is Eleuther AI's GPT-J model, 6 billion parameter language model. So I can say something like, "Hi Alexa," let's see, let's just see what it says here. It's running. Okay. All right. So it just completes the story. Hi, Alexia. I'm sure you know what I'm talking about. I had one last year. You can try different things. So I am putting in a different thing here.
And now it knows how long it takes, so like it kind of gives you an estimate. Okay.
Exactly. That's right. That's
That's
right.
smart.
Yeah. And so there once was a pineapple. Pineapple was pretty. It had pink leaves and so on. Yeah, exactly. So like you said, it can kind of it measures a runtime, so it gives you some idea of how long it should take.
Do pineapples have pink leaves?
I don't think so. I don't think it's a very truthful language model. Maybe this is more accurate though. Actually, the moon's orbit around the Earth has approximately 29.5 days. I think that's right.
Yeah,
Cool.
I think so.
Yeah, awesome. Let's go back to see if it finished. No, this one is still running. Okay, that's fine. Okay, so hosting the demo for free. So we've talked a little bit about this, and I won't go into too much depth here, but you can essentially host the model for free on Hugging Face Spaces. And we have the steps to do that inside this Colab notebook. You can create a Hugging Face account and then just kind of create a space, and then you just copy and paste your code. And then it'll create the demo for you right there. And the cool thing is, once you have this, then you can do things like embed that demo in other places. Let's say you have a personal website or a portfolio, then you can embed that demo there, and that can be kind of a cool way to show off the demos that you've built. Great. With that, I think I'll end the demo part. I'm happy to answer any questions that you have about anything that I shared.
Yeah, it looks really amazing. Like, must be not an easy project. So I'm wondering how many people are actually working on this.
Yeah, it's a good question. So we started off with 4 people working, like 4 founders of the company, 4 people working behind it. We've since then we've been very lucky to expand the team, and now we have 7 people that are working on this within Hugging Face. But that includes both the technical side as well as some of the outreach side and developer advocacy side as well.
And I guess you also have contributors who are
Oh,
outside
of course, yes. And we have I think at this point more than 60 contributors who contributed lots of different things, and we're very, very fortunate, yeah, to kind of everything from like translating. So there's one of the cool things is if you run Gradio in a different environment with a different browser language setting, it'll even change some of the displayed buttons and so on. To many of the features that you saw actually were contributed or fixed by people in the open source community, and we're very grateful for that.
Somebody from the open source community who doesn't work at Hugging Face wants to make a contribution. How should they go about this?
Yeah, absolutely. So check out our GitHub repo. So it's www.gradio.dev is like the short link for that. So Gradio, Gradio.dev, DEV. And then when you go, you'll see a lot of issues. And many of the issues are, like you can kind of take a look at them. And if there's something that you see that you want to work on, you're free to take it on, especially those that don't have like a PR already associated with them, of course. But actually, to be honest, probably the best way is give Gradio a shot. Like try using it, and you might notice, something that a bug that hasn't been reported, or an enhancement that you feel like could make your quality of life better. And then you can raise an issue around that and fix it yourself. That's probably the best. Those are kind of the most of the contributions that we get are exactly that. People notice an issue themselves. They're like, okay, let me go ahead and fix it. And so we really appreciate that.
Okay, nice. Do you have good first issues?
Yeah, so we have had that at some points. I don't know right now if there's any that are still active right now, but this conversation is making me think that I should go back and maybe tag at least a few so that by the time people watch this, there will be some good first issues.
Do you plan to take part in Hacktoberfest this year?
Um, it wasn't on my radar, but we'll take a look. Maybe it's a good suggestion. Yeah.
You have a lot of time till October, right, to figure this
Yeah,
out.
so yeah, we'll think about that.
Okay,
We'll think
so
about
what are your plans apart from thinking about Hacktoberfest?
Yeah, exactly. Um, so we are planning on so now that Gradio is out, so we recently released something called Gradio Blocks, which I didn't have time to go into in this conversation, but it's a kind of a more low-level API that allows you to build much more custom web components. So you just saw like kind of simple input-output demos, but let's say you want to do things like multi-step demos, or you want to have a lot more control over how things look in terms of the layout and so on. So we expose blocks for this reason. So blocks is kind of this like low level. It's supposed to be like the building blocks for your web application. So right now we're documenting blocks. We're building really cool blocks. We just had something called the Blocks Party, which more than like 50 people built really cool blocks demo. It's very sophisticated stuff, and you can like Google Gradio Blocks Party and check those out. So now that that's kind of in place, we're looking at now what else what other high level abstractions would be helpful for our users. So for example, so Gradio helps you understand models. What is the equivalent of Gradio for data sets? Like people want to understand their data sets as well. Can we help kind of build that? And so we're looking at different use cases. Also, another big one that comes up a lot is like bulk inference. So like, okay, it's cool to be able to drag and drop in a single sample, but what if I want to drag and drop in a bunch of samples? So things like that, we're thinking about that a lot, but we want to hear from users, what would be most helpful for you. So if you have any thoughts about that, you can kind of drop it on our GitHub or join our Discord as well. And the link to that is through our website. So the website is gradio.app.
You can also send all the links to me, to us, and then
Okay,
we'll include them in the description. So people who are
great.
watching this, you can just go to the description and click on everything we mentioned today. Maybe
Yeah.
I have a question that is somewhat technical. I'm really curious how this thing is implemented. So you have the backend running in Colab, but then you're actually exposing this model somewhere. But I don't think Colab allows you to open any random ports in the notebook. Like, how did
Yeah.
you pull this off?
Yeah. So it's a good question. So, yeah. So in Colab, it was tricky, but we basically did a solution similar to kind of ngrok. Basically, it creates an SSH tunnel between the local port and a port on Gradio.app's website on a Gradio.apps server. So we have a server that creates this SSH tunnel between that local port and this public port, and the idea behind the public port is just simply to forward any traffic through that, which makes kind of that local port and that local server and the local Gradio demo accessible. Which is why for Gradio for Colab notebooks that are running Gradio demos, there's always this public link that's created so that you can kind of access it. Otherwise, you wouldn't even be able to access the local port that was there. So yeah.
And this Colab, like, I didn't know that you can actually do this on Colab. I thought
Yeah.
it's like super close that you can, all you could do is, do your notebook
Yeah.
without doing stuff like SSH
Yeah.
tunnels.
Yeah. Luckily for us, they do allow that. So
Okay, good. Okay, well, do you have any advice for anyone who is watching this?
yeah, sure. I would say that one of the things that gets me really excited is even folks who are not typically consider themselves machine learning enthusiasts can now use and access state-of-the-art machine learning. And I do feel like machine learning is going to now become kind of the default way to build technology in the future. There's going to be kind of everything's going to be data driven and kind of continuously learning and improving. And so if you would like to try it out, we're trying to make the barrier to use machine learning lower and lower. And so give it a shot. Check out Hugging Face Spaces. I think it's really cool. It's very inspiring just to see like all of the different demos that people have built. Literally, like probably you'll see like it's timestamped, so you'll see like all the demos people have literally built in the last day. and you'll be kind of, I think it's very, very inspiring. So check that out, and we're looking forward to hearing from you through our Twitter or Discord or GitHub, or where you can find us in a lot of different places. So.
And you must have quite a good site reliability engineering team, because I imagine when something goes viral on Twitter, like your servers are still up.
Yeah, yeah.
Quite a good job.
Yeah, exactly. So we're an amazing infra team at Hugging Face that manages that. Exactly, you're right.
Okay, yeah, that would be it for today. So thanks a lot for joining us today. Thanks a lot for showing the demo. Amazing tool. Thanks for putting effort into creating this and making this open source. I'm pretty sure everyone appreciates that. That's really good of you. So thanks a lot.
Thank you so much, Alexei, for having me. Have a good one. Bye.
You too. Bye.